this video, we are going to be talking about different types of relations that we have. Let's take an example. A is a set. Let's say A has 1, 2, and 3 as the elements of it. Now, what are the number of subsets that I can have for this particular set A? We do have the set itself as its subset, and finally I have the null set, which is a subset of every other set. So the number of elements of A is 3, which is otherwise called as the cardinal number of A, that is 3, and the number of subsets is going to be 2 to the power of 3, which is 8. Now we are defining relation as a subset of the Cartesian product, isn't it? So let's take a set A, which is 1, 2, 3, and set B, which is 4, 5, and 6. Now quickly, I'm going to be writing all the ordered pairs belonging to A cross B. Let's define a relationship R. Pick up ordered pairs A cross B, where A is related to B in this fashion. A minus B is less than 0. Let's put a modulus around it. Basically, the difference between the two numbers is going to be negative. That's not going to be possible because the modulus sign itself takes care of me not getting a negative number, isn't it? Well, so there's no ordered pair satisfying this condition, and hence this relationship R is going to generate an empty set, a null set basically. So if I now go back to my sets, I do see that this particular set is a null set, and the same set in relation will be called as a empty relation. Okay, so basically a relation which is generating a empty set is an empty relation. Okay, now let's look at another example, another relation actually. Okay, let me define a relationship R. I'm going to pick up order pairs A comma B such that the modulus of the, or the difference between the two numbers is going to be greater than 0, where A is belonging to capital A and B is belonging to capital B. Okay, now let's see what are the order pairs satisfying this condition. Well, give it a thought and you will realize that the entire set A cross B belongs to this particular relation, simply because you can pick up any elements, the difference is always going to be greater than 0, isn't it? And hence the entire A cross B will be the part, or will be the relationship R. Okay, now let's go back. I saw that the set itself is a subset to the set. In a similar fashion, here I see that the relationship is taking up all A cross B. This relationship is called as a universal relation. Great. Now let's look at another type of relation. I'm going to now define a relationship R on the same set, which is A to be equal to 1, 2, 3. I hope you understand that A cross A is going to be 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and so on and so forth. Okay, now let's go ahead and define this relationship R. Pick up ordered pairs A comma B such that A is equal to B, and A and B both are belonging to the set A. So what are the order pairs belonging to this? 1 comma 1, 2 comma 2, 3 comma 3. So this is an identity relation. It is a relation where the element A will be related to itself and not to any other element. Now let's define another relationship, another type of relation, reflexive. Now before I can introduce you to reflexive relation, let me explain to you what is an equivalence relation. A relation which can satisfy three conditions or three type of relations. which is reflexive, symmetric, and transitive. A relation which is reflexive, symmetric, and transitive is an equivalence relation. Now we're going to learn what is a reflexive relation with an example. Let's pick up a relationship R defined on this particular set A. A cross A is what we will be concentrating upon. Okay, now I've defined a relationship R here, so you need to understand the elements belonging to A cross A. These are certain things that needs to be in your mind. We cannot be writing these every time. So certain things we need to keep it in our mind. This is a very small set, and hence we will be capable of writing A cross A, isn't it? But if the set is too big, like for example, if we had elements like 4, 5, and 6, and the 7, and the 8. Now, writing an A cross A is going to be too tough and time consuming. It's a waste of time. So we don't do that. So most of the times we remember or try to think about the type of set that we're going to get, or A cross A that we're going to get. Okay, we're not going to be writing that every time. Alright, now coming back to our example, 1, 1 and 1, 2, 1, 3, no, 2, 1, 2, 2, 3, 1, 3, 2, and 3, 3. Now all these belong to the relationship R defined as above. Now this is an reflexive relation, or this is a reflexive relation. Why? Because the element is related to itself. Well, I mentioned or made the same statement for another relationship, which was identity relationship or identity relation. Now if you look at this, here also A is related to itself, right? But this will not be a reflexive relation. It will rather be called as an identity relation, simply because it is restricted to A being related to itself, whereas in reflexive, A is related to itself and also to other elements. And that's the difference between reflexive relation and identity relation. Okay, so what did we learn in this tutorial? We learned the different types of subsets that I can have for a set, the number of subsets that I can have, set itself being a subset, and we learned about the null set. Now when we talked about relation, we talked about it as a subset of the cross product, isn't it? So here I defined a relationship which generated a null set, and hence this relation is called as a empty relation. And I had another relation which took the entire A cross B, and hence this relation will be called or given a name as a universal relation. Okay, now what else did we learn? We also learned about reflexive and identity relation. We also gave an introduction to equivalence relation. We understood the difference between reflexive and identity. In the next video, we will understand what is a symmetric relation, okay, and transitive. Thank you.